This video is all about solving logarithmic equations. So we've got logs and equations with variables in it. We got to solve for the variable. We've got the steps right here, 4 steps. So it's a great time to pause the video and write them down into your notes. Step 1, if you have multiple log expressions, you have to combine them together. This means condensing logarithms. If there's a constant on one side of the equation, then convert the log into exponential form. If there is a log on both sides, set the arguments equal to each other, and then solve for the variable. I believe all my examples I've got for you in this particular video, well, at least the first 4 of them, we've got a constant on one side. So here we go. Notice, I've got a problem, I've got an equation, I've got a couple of logarithms, and I've got some variables in there, an x right here. First, I have to combine my multiple logs together into one log. I need to condense them. Well, I see subtraction, that's going to turn into the arguments are going to have division. So that's going to turn into log base 5. And the 3x squared from here goes on top, and then my 3 from here goes on bottom. So log base 5, 3x squared over 3, still equal to 1. Okay, so I've got a couple things going on right now. First off, I have 3x squared divided by 3. Yeah, I'm gonna just cancel out those 3's. I don't need those. 3 divided by 3 is 1, it goes away. So actually what I have is log base 5 of x squared equals 1. Well, now I need to go ahead and convert it into exponential form. So my base is 5, my exponent is 1, and then my argument goes over here. Well, oh, I said 1 and I wrote a 2. I don't know why. Okay. So now I'm here. That's no big deal. 5 squared, or 5 to the first power is just 5, so I have 5 equals x squared. And to solve that, what I need to do is take the square root of both sides. So I'll take the square root of this side, take the square root of this side. Now, don't forget about the whole positive negative scenario. There's technically 2 square roots to 5, and that's positive negative square root of 5. If you're gonna do a decimal, then make sure you plug that into your calculator and get a decimal. In my class, it's fine to leave it as a radical, but don't forget to follow the directions for whatever teacher you have, whatever class you're in. This is fine for my class. The calculator will do the rest if you need a decimal. Okay, let's try that again. Okay, so I've got 2 logarithms. I need to go ahead and combine them together into one. Once again, I have subtraction. That's going to lead to division in the argument when I combine those together and condense my logarithms. So I've got log base 6, and I've got x plus 5 over x, and that's all going to be equal to 1. Okay. Well, that means I can go ahead and convert it to exponential form, and I've got 6 to the first power equals x plus 5 over x. Well, that's doable. We've got a couple different ways we can think about this. I need to get rid of this fraction. I could just multiply both sides by x. I could also think of this as 2 fractions, and I could do cross multiply, or as my Algebra 1 students sometimes call it, the butterfly method. Either way, that's going to lead me to 6 times x on one side and then x plus 5 on the other. Very doable. Now I'll just subtract my x from both sides, and that leaves me 5x equals 5. Divide by the 5. My final answer looks like x equals 1. Okay. Couple more. Notice this one's equal to a 2 instead of equal to a 1. So let's just keep that in mind, okay? So I'm going to condense my log. I've got subtraction. It's going to lead to another division in my argument. So I've got log base 3 x minus 3 over x equals 2. Okay, so put it all together. This is going to be 3 squared equals x minus 3 over x. The 3 squared turns into a 9. 9 equals x minus 3 over x. Well, now I can kind of cross multiply, same as I did before. That leads to 9x equals x minus 3. Subtract the x from both sides, and that leads me to 8x equals negative 3, x equals negative 3 over 8. Okay, but it's negative, so let's talk about this. Let's talk about this. So what happens, think about this. Log 3 of x, and the x is negative. This literally means 3 raised to some power, whatever it's equal to, equals whatever x is. Now, is there a scenario, is there a way that I can get 3 raised to any power in the world and I get a negative? Like, is that possible? I get 3 raised to any power in the world and get a negative number? Even if the exponent was negative, even if this was negative, that turns it into a fraction. That's not, a negative exponent wouldn't make this be negative. It might flip it upside down or something, but it wouldn't make this be negative. So that's not possible. No. So because this is negative, it's not going to work. Not going to work. Now, be careful, because if it's not just an x, maybe it's something like this. So maybe if I put a number in here and then add or subtract or do something else, maybe it won't be negative anymore. But in this case, no. There's just no way that I plug in a negative number for x and this works. So this one is no solution, okay? If you get a negative answer, just take a minute and think to yourself, okay, is there a way that this works? Is there a way that this works? And it's okay for x to be negative. That's fine. It's not okay for one of the entire arguments to be negative. For example, perhaps if I got a negative something for here, well, then I added 5 and the argument is not negative anymore. But for here, the arguments are negative, and that doesn't really work in a scenario like this. Okay, let's try this one. So for this one, I've got addition, so this is going to turn into multiplication in my argument when I condense my logarithm. So I've got log base 4, and it's going to be the 9 times all of this. I will end up using the distributive property here. So that's going to be log base 4 of 9x squared plus 9 times 7 is 63. Okay, time to turn it into an equation. 4 to the 3rd power equals the argument, 9x squared plus 63. All right. In this scenario, I'm feeling a little on the lazy side. It's fine to use your calculator if you've got it. So 4 to the 3rd power is 64, which means when I subtract the 63 from both sides, because that's what I have to do next, right? Subtract the 63 from both sides. Then I get 1. So right now I have 1 equals 9x squared. All right, let's bring it over where there's a little more room. 1 equals 9x squared. Divide both sides by 9. So I've got 1 over 9 equals x squared. Okay, time to take the square root. So I have x equals, well, I've got positive or negative square root of 1 over 9. 1 over 9, they're both perfect squares. The square root of 1 is 1. The square root of 9 is 3. So this is going to be positive and negative 1/3. Now, however, I better check and make sure that if it's negative, that's okay. Honestly, if that's negative, that is fine, because if it's a negative and it's squared, then it turns positive. So both our answers, the positive and the negative, are okay. That's fine. All right, one more problem. This is the last example for this video. Now, notice, we've got some different stuff going on. Back to our directions. If there's a log on both sides, set the arguments equal to each other. That is coming up right now, but we still have to condense our logs first. I've got logs all over the place. The ones that are on the same side of the equal sign, I'm going to condense those. So subtraction turns into a fraction or division in my argument. That's going to turn into log base 4, and I've got x plus 2 over x, and that's going to be equal to log base 4, 17. Well, if they're both logs with the same base, then the arguments must be equal to each other. So I'm just going to say x plus 2 over x has to be equal to 17. And I'm going to solve that. I'll cross multiply. That gives me x plus 2 equals 17x minus the x from both sides. 2 equals 16x. Well, divide by 16 on both sides and I'll be done. That simplifies, it reduces to 1 over 8. And I am done for today.